Today, I'm presenting a comparison between the performance of a standard 385mm Waffle raft and a Biax 215 with reference to the Australian standard 2870. The objective of this standard is to specify performance criteria as well as specific designs for footing systems, essentially for residential applications in Australia. Section 3 contains the standard designs, and Section 4 contains the engineering principles to be used to design. With a focus on waffle rafts, the standard provides, in figure 3.4, options that can be used for different site classes and for different type of construction. Section 4 is used to extend the range of validity or to modify the solutions within the deemed to comply designs. Designing by engineering principles can be done with a detailed calculation or with a simplified method. If the detailed procedure is selected, then a computer analysis is required, and Appendix F provides information and the methods that are recommended by the standard. And on the market, there are different software that follow these methods, such as Slog, Chord, and Waffle Suite. Today, I will focus on the simplified method because the detailed calculation requires knowledge of this software and the methodology underpinning their calculation. The simplified method is pretty straightforward and easy to understand in a simple video like this one. The simplified method is applicable to waffle rafts as they are considered as stiffened raft in the standard, because there are some limitations in the application of this method, such as the maximum soil movement as well as the loads. So there are a few limitations. But once we are within these boundaries, then we check only the stiffness and the strength of the footing system, neglecting, for example, the loads. Checking the stiffness is pretty simple. There is a formula that essentially is the inertia of the ribs or the footings in the ribs, neglecting the flanges. And the strength can be checked instead, simply ensuring that the ductility requirements contained in clause 4.4 is met. When we look at the stiffness of a standard 385 Waffle and the Biax 215, we notice that according to the procedure provided within the standard, the stiffness is identical. Both the system returns a value of 8.6. This is because although the 385mm Waffle raft is deeper, the Biax 215 has larger ribs, and the spacing is reduced, because in a waffle raft is 1.2 meters, whereas in the Biax 215 is 0.75 meters. From a standard viewpoint, the two systems have the same stiffness. In terms of strength, with reference, for example, to a solution where slab fabric 72 is used and an N12 bar is used at each rib location at the bottom, both solutions satisfy the ductility requirement. We can check whether the Biax 215 complies to the soil conditions and the type of construction. For example, if I look at an H1 site with articulated masonry veneer, I obtain a value of 2 for the ratio between YS and the maximum differential movement. Then, using the figure 4.1, the line I get by the intersection of the vertical line at 8.6 is above the value of 2. It means that I met the requirement. So this very, very simple calculation can show that a Biax 215 from a stiffness viewpoint, complies with the standard for an H1 class with articulated masonry veneer. Sometimes, when we follow the simplified method, but also with the detailed method, some of the solutions contained in figure 3.4 are not satisfied, but that's a topic for another video. So my conclusions are that a standard waffle raft with a depth of 385 millimeter and a Biax 215 can be considered to have equivalent performance according to the provisions of the standard 2870. Thank you for listening.